some of them and then we will proceed to discuss certain new things. Let us quickly recall what is electric current. Electric current is the flow of electrons through a conductor. And if you have a wire and you just hold the wire between your hands or you leave it on the table, the current will not flow. The current is only flowing through a wire when you connect it to the source of charge, which will give the energy to electrons to flow. And the device which causes the flow of electrons through a conductor is called a cell or a battery. And whenever charges flow, they will flow from negative terminal to the positive terminal. And electric current is considered to be going from positive to negative. If you will look here, you will understand that we say that electrons move from negative to positive. But when the electric current was first discovered and when people studied about electric current, at that time electron flow was not known. Therefore, the direction of conventional current, conventional electric current is taken from positive terminal to the negative terminal of the battery. Now, if we consider electric current, then we need to discuss about expression for electric current. So, through a wire, current is flowing by means of charge Q. Therefore, electric current is defined as the rate of flow of charges through a conductor or the quantity of charges flowing through a conductor per unit time. This will give us the formula for current as I equal to Q upon T, where Q stands for the quantity of charge, I capital I stands for current and T stands for time. Now with this, the SI unit of electric charge is coulomb, and if electric charge is coulomb, so I will be 1 coulomb upon 1 second, and one standard unit of current will be named as ampere. So you can see here unit of current is ampere. And how do we define 1 ampere then? 1 ampere is the current flowing through a conductor if 1 coulomb of charge flows through it in 1 second. Now once we are allowing the current to flow through a conductor, we are measuring it, then we need an instrument to measure it. So the instrument which is used to measure electric current is called ammeter. And it is always connected in series in a circuit. And it is connected in series because then only it will measure all the current which is flowing through a circuit. Now we are repeatedly mentioning the term circuit. So let us quickly revisit and recall what is an electric circuit. So when we consider an electric circuit is a path in which electrons from a voltage or current source flow, and the point where those electrons enter in an electric circuit is called source of electrons, that is the cell or a battery. So in short, we can define electric circuit as a continuous and closed path of current flow. So you can see here there is a switch, there is a resistor being connected to a battery, current is flowing in from positive to negative and electrons are flowing from negative to positive. And please understand, if the wire is broken anywhere or you have left the switch open, then the current will not flow. The current will only flow when you have provided a closed and continuous path for current to flow. Now once we discuss about electric current flowing through a circuit, and we know that cell or a battery is the source of electric current which is making the electrons flow, then we need to discuss about electric potential and electric potential difference, which is being provided or which is being created at the ends of a wire or the ends of a circuit by means of a cell or a battery. So electric potential is the capability of a charge to move a unit charge from one point to other. And when we consider electric potential difference, it is the work done to bring a unit positive charge from one point to another. So if I write its formula, potential difference is denoted by a symbol capital V and it is given by work done capital W divided by charge capital Q. And the SI unit of potential difference is voltage. It is measured by an instrument voltmeter. Let's discuss it once again. Look here now. You have a charge being brought from a point at infinity to a point A. You can see here then the work done in moving this charge from infinity to that point is called electric potential. And if you have two such points A and B and the difference between the potentials of these 2 points is called potential difference. Now, why is it so important? Why are we discussing potential difference? Electric current will flow through a conductor only if there is a difference in electric potential between the two ends of a conductor. If you have a wire and you have not connected it to a cell or a battery, it means that both ends of the wire, the potential is same. And if the electric potential is same, the charge will not flow. There will be no flow of electric current through it. So you are able to make electric current flow only if you create potential difference. And what is what creates the potential difference? That is being given by a cell or a battery. And what happens in a cell or battery? The chemical reaction in the cell produces potential difference between the two terminals and sets the electrons in motion. It is actually the chemical energy getting converted to electrical energy. So the chemical reaction will make the electrons in motion and will produce electric current. So with this we have expression for potential difference. Now let us revisit it again. Potential difference between 2 points A and B of a conductor is the amount of work done to move a unit charge from A to B. So potential difference will be work done upon charge. Capital V is equal to capital W upon Q. And the SI unit is named in honor of a scientist and it is named as volt. Now how will you define 1 volt? 1 volt is the potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to other. So 1 volt is 1 joule upon 1 coulomb and it is measured by an instrument called voltmeter. Now when we are measuring potential difference, we are actually measuring it between 2 points. And if we are measuring it between 2 points, we will connect the measuring instrument between those 2 points. And that is why we always connect potentiometer or voltmeter in parallel between the points. It is always connected in parallel across the 2 points between which the potential difference is to be measured. Now, let us discuss circuit diagram once again. Now, what is a circuit diagram? Electric circuit was a closed and continuous path of current flow. Now, you can see a lamp looks like this. We have shown you a picture of a battery, a lamp and a switch. Now, if you are to draw it on paper, it is very cumbersome to draw each and every device in its actual picture. Therefore, we use a circuit diagram, which is also called an electrical diagram, elementary diagram or electronic schematic. It is a graphical representation of an electric circuit. And while drawing a circuit diagram, we make use of symbols. We represent each electrical component by a symbol. So these are certain symbols. An electric cell represented by a longer line and a smaller line. Longer line represents the positive terminal, smaller as negative. We also have if you move towards the right hand side, a battery or a combination of cells. So you will put 2 or 3 or 4 cells together. A plug-in key where you actually put in the key and you take it out, or you can even use a tapping key. You tap like your belt switch, a tap key, and there are different symbols for open key and closed key. Open key means the circuit is broken, current is not flowing. Closed key means that the circuit is closed and the current is flowing. Then we have a symbol for electric bulb, a resistance, a variable resistor or a rheostat in which we can change the obstruction to be offered for the current flow. It has two different symbols. Then we have a symbol for ammeter, which is a circle with the capital A inside and positive and negative terminals mentioned. Similarly, we have a voltmeter symbol, a wire joint. When two wires are joined together, we show a solid dot. And if they are just crossing over one another, we don't put a dot there. So these are certain symbols. Now, we will be discussing how we use these symbols in different electric circuits. And let us first discuss the relationship between the two measurable parameters about electricity. We have studied about electric current and we have studied about potential difference, which is making the current flow. So next thing which we have to discuss is the variation of electric current by changing the potential difference. If we will increase the potential difference, how will the current change? Or if we decrease the potential difference, how will the current change? And this whole relationship was studied and was given in a law which is known as Ohm's law. So when we consider Ohm's law, this law says that the current flowing through a conductor is directly proportional to the potential difference between its ends, provided all the physical conditions remain the same. This implies if you increase the applied potential difference, the current will increase. If you decrease the applied potential difference, the current will decrease. Now, let us discuss how we can verify it. Now, for verifying it, we have this circuit. We have a source of electric current. We have connected it through a switch to a conductor, and then we have put a rheostat for varying the resistance of the conductor, and for measuring voltage we have connected a voltmeter, and for measuring current we have connected ammeter. Now you can see the actual picture of the components and you can also see the schematic diagram. Now what we will do here? We will set up this circuit as shown in the circuit diagram. Then what we will do, we will first use one cell and note the current in the ammeter. Then potential difference across the voltmeter using the voltmeter across the nichrome wire. Then what we will do, we will repeat the same experiment with 2 cells, 3 cells and 4 cells and note down the reading in the ammeter and voltmeter. And once we have noted the reading of voltmeter and ammeter, we will plot a graph between the current and potential difference. Now this graph is found to be a straight line. And whenever we have two quantities and we plot a graph between them and we find that the graph is a straight line which is upward going, this shows that the current through the conductor is directly proportional to the potential difference across its ends. So now V is directly proportional to I, or V is equal to IR. Now R, capital R, is the proportionality constant, which is also known as resistance of the conductor. So if you plot the graph, you can see here that V versus I graph will be a straight line. Now let us discuss what is this proportionality constant, which is known as resistance. So resistance is defined as the hindrance or obstruction to the flow of current. It is given by the ratio of V and I. V upon I is R. Its SI unit is volt per ampere or ohm. To honor the scientist, we have named the unit of resistance as ohm. And reciprocal of resistance is called conductance. Now if you look here, R is equal to V upon I. So if there will be high resistance, the current will be low. And if you have a low resistance, the current will be more. So resistance and current have inverse relationship. By increasing resistance, you can decrease the current. Next is, so resistance is The property of a conductor to resist the flow of current through it. According to Ohm's law, R is equal to V upon I. SI unit, ohm. Now how will you define 1 ohm? If the potential difference across the two ends of a wire is 1 volt, the current flowing through it is 1 ampere. So if the voltage is 1 volt and the current is 1 ampere, then we say that that conductor is offering a resistance of 1 ohm. I is equal to V upon R, and current is inversely proportional to resistance. If resistance is a double, current will get halved. Now once we know what is resistance, we need to know what are the factors which will be determined in finding the resistance of a wire. Because ultimately we are going to lay down electric circuits, and when we lay down electric circuits, we need to control the current flowing through it. Because every appliance has a different current requirement. So let us discuss factors affecting resistance of a conductor. Now it is said that the resistance of a conductor depends on length, area of cross section, material of the conductor, and it is directly proportional to length. It means if you increase the length of the conductor, the resistance will increase. And it is inversely proportional to the area of cross section. So R is proportional to L upon A. And if you remove the proportionality constant, R is equal to rho L by A, where rho is called proportionality constant, which is also called resistivity of the conductor. Now SI unit of resistivity will be ohm meter. Now conductors like metals and alloys have low resistivity, and insulators like rubber, glass have high resistivity. So what we were discussing, we are saying that R is proportional to length, it is inversely proportional to area. Combining this, we have got the resistivity. So resistivity or resistance depend on the type of material also. Wires having same length and thickness but made of different material will have different resistances. If you have a copper wire and an aluminium wire or a silver wire, they all will have different resistivities even if they have same length and same area of cross section. This is because they have different resistivity. So materials, silver, iron, polythene, they have given you the resistivities. Silver having low resistivity will become a good conductor. Iron, a conductor. Polythene is a very good insulator. It will not allow current to pass through it. Once we have controlled the current flowing through a conductor by varying its resistance, then we need to know how should we connect the conductors if we want to increase the resistance, or how should we connect them to decrease the resistance. And that comes in terms of combination of resistors or combination of conductors. So therefore, the first kind of combination is resistances in series. Say we have taken 3 conductors with resistance R1, R2 and R3. So like you are standing in a queue, that is one after another, that is called serial order arrangement. Similarly, we have taken 3 wires, 3 conductors, we have connected them one after another. So it is resistances in series, R1, R2, R3. Now what will happen? We complete the circuit, we connect it to a source of electric current, a battery, a switch, a measuring instrument for measuring current, ammeter and the voltmeter, and we allow the current to flow. Now when we allow current to flow, the current in all the resistors is same, because the current will have only one path for its flow. Now since it is having only one path to flow, it will pass through R1, then R2, then R3. The current will be same across R1, R2, R3. The current cannot change. So that is why we say series current constant. In a series circuit, the current will always remain same. But what will happen? The potential will get divided. And therefore, the potential which we are supplying from the battery or cell, capital V, will be divided to V1 plus V2 plus V3. Now we know Ohm's law. We know that the capital V is equal to I R. Similarly, V1 will be I R1, V2 will be I R2, V3 will be I R3. I is on both the sides, you can cancel. And then you will get the equivalent resistance is the sum of the resistance of each resistor. Therefore, the total resistance R is equal to R1 plus R2 plus R3. So, if you look at these circuits, we have series combination. Capital V is V1 plus V2 plus V3. Now, there is another kind of combination which is called parallel combination. In parallel combination, what we have done, we have provided different paths for current to flow. We have put the resistors R1, R2 and R3 one above another. Now what will happen? The potential difference is same because both the ends of each resistor is in direct contact with a cell or a battery. Since they are in direct contact, the potential across R1, R2, R3 will remain same. But the current has options. Current can go through R1 also, R2 also, R3 also. And since current can go through either of these three, the current will get divided. Therefore, the net current capital I will be equal to I1 plus I2 plus I3. Again, using Ohm's law, you can substitute for I, V upon R, and substituting that we get 1 upon Rp. The net resistance will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So, in this circuit, you can see that if you have the lower one, you can see if you have three resistances which are connected in parallel. You can see the derivation also. I1 we are writing V upon R1. I2 we are writing V upon R2. I3 is V upon R3. So the net resistance I is equal to I1 plus I2 plus I3. You will substitute and you will get the net resistance 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If you have 10 such resistors, the formula will continue. What will happen if you compare a series circuit with a parallel circuit? In a series circuit, the net resistance will increase, while in a parallel circuit, the net resistance will get decreased. So, if you have two lamps being connected in series, the net resistance of them will get added. But while if you have two lamps which are connected in parallel, the net resistance will get reduced. And therefore, parallel combination is preferred over series combination. In parallel, what will happen if you switch off one device, the other can work easily. But in series, what will happen? If you switch off the lamp 1, the lamp 2 will also not work. The lamps will work simultaneously. And therefore, series combination is not preferred and parallel is preferred. Now, we have discussed about combination of resistors. We have discussed about the current flowing through those resistors. What is making the current flow, the potential. Now, we have to discuss about electrical energy. The energy which is making all this happen. Now, what is electrical energy? You all know that energy is capacity to do work, and work is related to electric potential by VW. V is equal to W upon capital Q. So what will be W? W will be potential multiplied by the charge, and that work done is equal to electrical energy. So the electrical energy is the work done to maintain the flow of current in a conductor. W will be equal to Q into V, and now you can substitute for capital Q from the first formula I equal to Q upon T. Q will be equal to I into T, and for V also, capital V also, you can substitute from Ohm's law IR. So you can see here, substituting, we get W is equal to I into T into capital V, or W is equal to I square R T. Now what will be the unit of energy? Same as work, that is joule. Now once we define electrical energy, for any electrical device, we need to define electric power. And the power will be the rate at which electrical energy is consumed or electrical current is used. So power will be work done upon time. P is equal to W upon T, I square RT upon T. T cancels, I square R. So the formula for power will be I square R. Now instead of I square, you can substitute from the Ohm's law expression and you can find power is equal to V into I. The potential multiplied by the electric current. They are changing and they will ultimately change the power of the device. Now what will be the SI unit of power? Watt. And how will we define now 1 watt for an electrical device? It will be when 1 ampere of current flows across a potential difference of 1 volt. A device which is having say 1 watt of electrical wattage, we say it means that a current of 1 ampere flows through it whenever we supply a potential of 1 volt. Now, we know that 1 watt is a smaller unit of power. So, we define 1 kilowatt which is equal to 1000 watt. Now, in commercial electrical devices, when you write about electrical energy consumption, we write it in terms of kilowatt hour. Because if you take times unit as second and powers unit as watt, they become very small unit. So we define 1 unit as 1 kilowatt hour. And 1 kilowatt hour is 1000 watt into 3600 seconds. There are 3600 seconds in an hour. So it will be 3.6 into 10 raised to power 6 joules. So when you are running your ACs or your fans or your tube lights, you can make out, they will say that it has consumed, like you buy any new refrigerator, they will say it consumes only 1 unit in a day. Now 1 unit means it consumes 3.6 into 10 raised to power 6 joules. Though it is still lesser than what the older versions of refrigerators used to take. Now the commercial unit is kilowatt hour and 1 kilowatt hour is the power consumed when 1 watt of power is used for 1 hour. Now heating effect we have discussed. So if I is the current flowing through the resistor R in time t, we can write that work done is Q into V, that gives us heat it produces equal to I square R T. Now this is known as Joule's law of heating. Joule's law of heating says that whenever you increase the current flowing through a conductor, you increase the resistance of the conductor or the time for which current is flowing, you can actually increase the heat energy which is being produced in it. We are using devices like electric iron where we convert electrical energy to heat energy. So we want to know how much heat energy is being produced. Now that heat energy depends on I square RT. It is same electrical energy, but that electrical energy can get converted to heat energy in a device. It can get converted to a magnetic energy also. You will be studying about magnetic effects of electric current in the next chapter. It can get converted to chemical energy. You can utilize electrical energy to do a chemical reaction, a chemical analysis, electrolysis, electroplating. So that is another thing. But if you are using an electrical heating device, in an electrical heating device like your hair dryer, you are converting electrical energy to heat energy. So now let us summarize the whole chapter. When we consider the summary of the chapter, we have discussed electricity is potential difference is equal to work done upon charge. Then we are going from right to left. So potential difference is work done upon charge. Unit of potential difference is volt. The law relating potential and current, Ohm's law. V is equal to I R. Resistance is potential difference upon current. And what are the factors on which resistance depends? That is being given in terms of resistivity. And unit of resistivity is ohm meter. When you combine the resistors, they can be in series and parallel. Then when we consider Joule's law of heating, the heat generated is the electrical energy which is given by the formula I square RT or VIT, and it is measured in joules. And electrical energy leads us to electric power. So electric power is given by the formula VI and unit of power is watt. So happy learning. Thank you.